Tell us your name and tell us about your project.
My name is Quentin Davison, and in our experiment, we fired a beam of electrons from an electron gun onto a nickel target and studied the diffracted beam of electrons at different angles using a movable Faraday cup.
What were you guys trying to do or find?
So our original goal was to study the interaction between an electron beam and the surface of a piece of nickel at different incident angles. We had anticipated that due to the small size of the electrons that compose the fired beam would be scattered randomly due to the relatively uneven surface of the nickel. However, that was not the case because before this, we had noticed some oxidation build up on the surface of the nickel and heated it up to help get off the oxidation. This caused the nickel to form into a large crystal surface, which helped us to get better results.
Where did the project experiment occur?
So we did it at the Bell Telephone Laboratory located at 463 West Street, New York.
What other significant events were happening around the world at the time?
So during the 1920s, when the experiment occurred, it was a period of major success for most, especially in the United States. And it was the period known as the Roaring Twenties. So more people owned cars and other consumer goods than ever before. More people lived in cities and elsewhere other than in the United States. The USSR was founded, and then the fascist government in Italy was also founded. And of course, many women gained their right to vote in the 1920s. And then this was all before the stock market crashed in October of 1929. And that's about it.
Who else was involved in this project?
So I worked with my partner, my fellow physicist, Lester Germer.
What was your role in the project?
So starting in 1921, I had been studying the effects of shooting electron beams at objects, and I continued to study this through 1925. Then around 1926, I went to a conference, and at that conference, I realized that my work had become important because it was used as evidence to confirm Louis de Broglie's hypothesis about wave-particle duality. And after attending this conference, I sort of improved my experimentation and then obtained the results that I did get. So,
what impact did your project have on the physics community?
So because we discovered that electrons interfere either constructively or destructively, we confirmed that particles can have wave properties in addition to having particle properties. So through this experiment and its results, we helped prove that de Broglie's hypothesis about wave-particle duality was in fact correct, which was a major breakthrough in the quantum physics realm.
Have you received any awards for your work?
Yes, in 1937, I received the Nobel Prize along with George Paget Thompson, who also discovered the duality in 1925, which is around the same time that I and my partner discovered it. All right, thank you very much. Have a nice day.